This video is going to conceptually build up the electric field from the force that we've been using with Coulomb's law. But before we do that, I want to talk about gravity and the way that we describe gravity. So imagine we have some block of mass m in the presence of a gravitational field, and we have the force that's acting on this. Now, I already mentioned, in some sense, where I'm going with this, and that's to talk about a gravitational field as opposed to the force that's acting on this block. So imagine this block wasn't there. The Earth would still create a gravitational field. The force doesn't just pop into existence because you had a mass there. You could move this mass around, you could put it in different places, and it would still experience the force of gravity. So that's, in some sense, what I mean when I'm talking about a gravitational field. But we can extend that same idea into a discussion of Coulomb's law and the electric field. So imagine you have some charge here, call this some plus Q1, and you put another charge near it. You call this one a plus Q2. We know from what we've seen in Coulomb's law that Q1 is going to act a force on Q2 to repel it. So this is going to go up like this. So here's our F1, 2. But we could move our Q2 around. We can put it over here. And now the force is going to go that way. Or over here, it's going to go that way. Or over here. And we can complete a circle where we're talking about the force that is acting on this. And now what we can do is we can say that really we don't need this charge Q2 to talk about what might happen if we had a Q2 there. And that's the extension that we're having when we're talking about how we're going from force. So we're going to force to electric field. Same way we talked about going from the force and gravity to talking about a gravitational field. And so what does that look like in practicality? Well, what we would do is we would say that if we had some positive charge here, it's a positive charge, this emits electric field away from it. So that if I put another positive charge near it, it would be repelled. But we don't need that other charge there. We can talk about what's happening purely in terms of the field. Likewise, if we had a negative charge, we would have our electric field lines pointing in towards the negative charge. Okay. Now, this is conceptually how we can think about the electric field, but we also want to talk about this analytically and see how can we go from the force to the electric field in terms of the equation. And so the way that we're going to do that, let's write down our Coulomb's law again. This is F12 is equal to 1 over 4 pi epsilon naught Q1 Q2 divided by r squared times r hat 1, 2. The equation is very similar. We're going to say that this is going to be E, the electric field, is going to be equal to 1 over 4 pi epsilon naught times Q divided by r squared times r hat. Essentially the same thing. We're just removing a charge. So the thing that connects these two things together is the equation that the force is going to be equal to Q times E. So if you have some electric field produced by a charge, the force that is experienced by another charge is the amount of charge times the electric field that the first charge is producing. Nice. So something else that we can do with this is we can talk about distributions of charge. And again, this is a very natural extension. And in terms of when we're thinking about how we're going to do calculations, it's essentially the same. We're just removing one charge. So we have something that looks like this. So this is how we could figure out what the electric field is from a distribution of charge. Now, I want to talk very briefly about how this and this manifest themselves in the pictures that we have here and here. So Q is still the amount of charge. And if it's positive, we plug in a positive charge. If it's negative, we plug in a negative charge. And this r hat is going to point from the charge radially away to the point of observation. So let me talk about what I mean here. Radially away from the point of from the charge to the point of observation means if I want to find what the electric field is somewhere, that unit vector r hat is pointing from where the charge that's producing the electric field is to where I want to find the electric field. Now, the last thing that I'd like to say is this equation right here is actually the first part of what's called the Lorentz force law. And I'm going to write this to include the magnetic field. We'll get to this term right here after the second exam. This will be material on the third exam. But the important and interesting thing about this is I don't even really need to know what's producing this electric field. I just say there is some electric field in space. What is the force that would act on a charge? There are several different types of problems you can do with that. So this is a short and sweet one. I hope you guys enjoy it. Take it easy.